Hello student. Today we are discuss about the DMA controller. We have selected the fifth unit. First topic is A237 DMA controller. Here we have discussed about the introduction of DMA control, A237 DMA about the A237 DMA controller, then CPU controlling and what is the DMA controller. After that you have performed your assignments. Then what is the DMA controller? Stands for the direct memory access. It is the method of allowing data to be moved from one location to another in computer without interventions from the central processor, that is the CPU. DMA is also a fast method of transferring the data within or and sometimes between the computers. DMA input-output techniques provides the direct access to the memory while microprocessor is temporarily disabled. The DMA controller temporarily borrows the buses, address bus, data bus, and control bus from the microprocessor and transfer the data directly from the external device to the series of memory locations, and same process they have performed vice versa. Basic DMA operations. Two control signals are used to request and acknowledge a DMA transfer in the microprocessor-based systems. First one is the hold HOLD signals as an input to the processor is used to request a DMA action. Second one is the HLDA, that is the hold acknowledgement signal as an output that acknowledges the DMA actions. When the processor recognizes the hold, it stops its execution and enters hold cycles. Hold input has higher priority in compared to the interrupt request INTR or non-maskable interrupt, that is NMI. Reset have the higher priority in compared to the hold. Hold acknowledgement, that is HLDA, becomes active to indicate that the processor has placed its buses at high impedance state. DMA definitions. DMA normally occurs between an input-output device and memory without the use of microprocessor. A DMA read transfer data from the memory to the IO device. A DMA write transfer data from IO device to memory. The system contains separate memory and I/O control signals. Hence, the memory and I/O are controlled simultaneously. The DMA controller provides memory with its address, and the controller signal selects the I/O device during the transfer. Data transfer speed is determined by the speed of the memory device or a DMA controller. In many cases, the DMA controller shows the the speed of the system when transfer occurs. The serial PCI, that stands for the peripheral component interface, express the buses transfers data at rates exceeding DMA transfers. This is the modern system has made the DMA less important. The A237 supplies memory and I/O with control signals and memory address information during the DMA transfer. Actually, a special purpose microprocessor whose job is high speed data transfer between memory and I/O. That is the diagram showing the CPU control the buses. Similarly, we are showing the say in next diagram where DMA control operates the buses. Here we have seen that when the CPU have controlling over the buses, all the connections from the memory regarding address bus, data bus and control bus are only connected with the CPU. In case of the DMA operates, all these three address bus, data bus and control bus are not connected with the memory. They are from memory not connected with the CPU, that is connected with the DMA controller. A237 is not a discrete component in modern microprocessor-based system. It appears within many system controls chipsets. A237 is a 4-channel device compatibility with 8086 and 8088 adequate for a small system. Expandable to any number of DMA channels input, A237 is capable of DMA transfers at rate of up to 1.6 megabytes per second. Each channel is capable of addressing a full 64K bytes operations of memory. That are the assignments you just complete it and submit.